crop tree release thinning is a pre-commercial technique typically applied to hardwood stands, where a certain number of high-value trees are released per acre. It offers a chance to influence species composition on the most productive sites. The technique is often used to focus site resources on species with either high timber value potential or species of significant importance to wildlife. Northern red oak is an example of a species often favored by this treatment for both of those reasons. So crop tree release, again conducted in really high quality hardwood stands, is implemented after the dominant trees in the stand have had time to express their dominance, typically beyond 10 years of age, 10 to 15 years of age. The treatment involves choosing maybe 50 to 70 crop trees per acre to be released, maybe less than 50 per acre to be released. And the spacing doesn't have to be necessarily uniform. You're not worried about spacing so much as releasing these really promising trees from competition. The release occurs through what we refer to as a crown touching approach. This slide here provides an illustration of the crown touching release approach. During a crop tree release treatment, you only remove trees directly competing with the chosen crop trees. What that implies is that their crowns are touching the crop trees' crowns, and so the crop trees are released on at least 3 or 4 sides, as the slide illustrates. Low thinning is a commercial thinning practice. Commercial meaning hopefully the landowner is making money on this one, not paying for it as an expense. And with low thinning, trees are removed strategically from the lower crown classes at a specified severity. Applied correctly, the smallest trees in the lower crown classes are removed to benefit the larger, more vigorous trees in the upper crown classes. This essentially mimics the natural mortality likely to occur eventually in an overstocked stand, or as a stand becomes overstocked. By thinning, we have the ability to capture the value of the trees that are likely to be outcompeted. We have the ability to influence what trees are left behind rather than just leaving it to chance. And we have the ability to maintain the vigor of a middle-aged stand. Crown thinning involves the removal of trees from the upper crown classes to benefit the trees in those same crown classes. This type of thinning was developed to overcome some of the limitations of low thinning, which often has only a minimal impact on the trees left behind, because with a low thinning, the trees that are cut are usually pretty small, and they're not very vigorous competitors to begin with. So to have any kind of real ecological impact or any kind of positive impact on the residual stand, you really had to remove a lot of those little trees. And so in lieu of removing a lot of the lower crown class trees, by removing just a few select competitors from the upper crown class, you can essentially have a greater impact resulting from your thinning operation, a greater positive impact resulting from your thinning operation. This type of thinning is really like a commercial crop tree release. You're focusing site resources on the most promising trees congruent with the objectives of the landowner. Alright, so those are thinning treatments. Intermediate treatments designed to tend to the existing stand and designed to leave an optimal number of trees of the most desirable species to fully utilize the available site resources. These last few slides will describe the most common regeneration treatments, treatments that are designed purposefully to initiate the establishment of a new stand of trees, of a new cohort. And so again, it's important that we use functional definitions here. The regeneration treatments you choose to implement are based on the requirements of what you hope to grow next, and they are based on whether you desire an even-age structure or an uneven-age stand structure. They are also based on what type of operation is financially feasible. Sometimes what you would like to do isn't exactly what is possible based on economic constraints. But above all else, what you need to be able to recognize is the difference between timber liquidation, timber mining, and a deliberate management action designed to reach a particular ecological or silvicultural goal. So we'll start with even-aged regeneration treatments, and right off the bat, we'll hit the most controversial of these treatments, the clear cut. By definition, a clear cut results in a forest opening large enough so that the influence of the surrounding vegetation is minimal. Generally speaking, you reach this condition at the very middle of a gap that's 2 to 3 times the height of the surrounding trees. With trees on average 80 feet tall, a gap that's 3/4 of an acre or an acre in size generally results in this condition. So for a clear cut to be a clear cut, the majority of the area has to fall within this classification of being minimally affected by the surrounding vegetation. So really, by the time you get above an acre and a half, you start to hit this definition. Clear cuts can be used in a positive way for a variety of reasons. They can be used to promote the establishment of shade-intolerant species and species that maintain seed banks in the soil. And equally as important, they can be utilized to create patches of early successional forest, young forest for wildlife species that require that as a habitat component. Seed tree harvests are designed to promote the establishment of shade-intolerant species as well. In this instance, the scattered overstory of trees is left behind as a seed source. This is a common technique to naturally regenerate species with light seed and wind-dispersed seed, like loblolly pine or shortleaf pine. The initial harvest opens the stand-up, leaving behind the seed trees on the order of 8 to 12 per acre, and so this is a negligible amount of shade. There's not enough shade left to affect what's growing next. Those trees are just left there as a seed source. Following seedling establishment, those seed trees are often cut to leave the newly regenerated stand free to grow. The last even-age regeneration technique we will discuss is the Shelterwood method. With this technique, trees are left behind to provide a specific amount of shade based on the requirements of the desired regeneration. The canopy density is altered based on the light requirements of what you hope to grow next. The goal is to allow regeneration, typically species intermediate in shade tolerance like white pine and most of our oak species, to become established in the understory and grow into competitive positions prior to the removal of the overstory. Shelterwood harvests can consist of a series of 2 or 3 cuts. The initial cuts are designed to decrease the amount of shade gradually. Once the regeneration has reached a competitive position, usually 10 to 15 years later, when saplings are at least 10 feet tall, then the overstory is removed. So those are even-aged techniques, regeneration techniques designed to establish a new cohort of trees, or one single age class in one shot. Our uneven age regeneration techniques include group selection and single tree selection. As uneven age systems, they are designed to establish or work towards a conceptual balanced age class distribution, where in theory there is a constant ratio between age classes and diameter or size classes. This is established by harvesting a certain number of trees from each age or each size class every entry, as determined by the chosen cutting cycle. That could be 15 years, 10 years, 20 years. The idea is that you are thinning the younger age classes and regenerating the portions of the stand that are older by removing mature trees as well. Regeneration becomes established, or it is released from the understory by the removal of single mature trees or groups of mature trees up to about 2/3 of an acre in size or smaller. Remember, beyond this 2/3 of an acre or up to an acre, you start to get these conditions of a clear cut, ecologically speaking. In the southern Appalachians, where most of our important tree species are generally shade intolerant or intermediate in tolerance, group selection is a lot more applicable. Single tree selection systems are employed in regions like New England and parts of the lake states where shade-tolerant species like sugar maple and red spruce are both abundant and ecologically and economically important. And so it's important to recognize why we choose one harvesting system over another. Broadly speaking, even-age systems are employed to grow shade-intolerant species. Again, you can accomplish this with uneven-age silviculture if your groups are big enough. But even-age systems, are kind of geared towards these shade-intolerant species, and they're also developed to establish or maintain large blocks of functional early successional habitat or young forest habitat for species that require it. The golden-winged warbler is a species of concern right now in the southern Appalachians that requires these kind of larger blocks of early successional habitat. Even-age systems are generally easier to administer from an operational perspective, and you're essentially choosing to cause one major disturbance every 80 years or so, depending on the rotation, versus causing several smaller disturbances every 15 years or so, depending on the cutting cycle, under an uneven-age system. In contrast, uneven-age systems are used to grow shade-tolerant species or species intermediate intolerance. Again, some intolerant species can be accommodated if the gaps are large enough. But these uneven-age systems geared primarily towards more species that are more shade tolerant. They're also employed to maintain these late succession characteristics of older stands, more mature stands. Coarse woody debris on the ground. Larger trees, standing dead trees, that sort of thing. The characteristics you'd find in older forests. There's also less of a visual or aesthetic impact associated with these treatments, typically speaking. There's an assumption by some folks that this type of harvesting minimizes the ecological impact of harvesting. And this is kind of tricky. This is not necessarily true. It's definitely not true some of the time. With all harvesting systems, the most significant damage typically associated with timber harvesting is erosion and soil disturbance as a result of the use of equipment or whatever's bringing the wood, whatever's bringing the trees out of the woods. The biggest impact in terms of soil damage typically occurs on forest roads and trails, skid trails and roads established for harvesting. You end up establishing those both for even-age systems and uneven-age systems. So the need for quality, well-designed harvesting infrastructure is necessary for both of these systems, even-age or uneven-age. And if done poorly, that's where you have a really big impact. That's where you have long-term, site impacts that cannot be repaired, right? And this can occur under both even-age and uneven-age systems. And so that's something important that you guys should take away from this. And it's important at the end here just to remember why we implement silviculture. These big questions of why we manage it all. And it's not to belabor this, but it's something that you will, as a forest practitioner, this is a question you get asked a lot. We do this because as members of the natural community, we need to utilize the resources of the earth to survive. In terms of forest resources, through sound silviculture, we can manage that use, we can manage that need sustainably. Again, we are trying to mimic the disturbance we see in nature to achieve our own ends, keeping in mind that our impact is so far-reaching at this point that when we choose not to do anything, to not manage an area, to not directly interact, that has an ecological impact as well. And just to wrap this up, nobody said it better than Aldo Leopold. I'll let you guys read that quote for yourself. And I encourage you all to be intelligent tinkerers as you progress in your careers.